Hi friends, in this video we are going to talk about Armstrong numbers. So in this video we are going to understand that what Armstrong numbers are, and we are going to write a code in Python to check whether a number is an Armstrong number or not. So friends, starting. What are Armstrong numbers? So numbers whose sum of cube of every digit is equal to the number itself are called Armstrong numbers. Let's understand these numbers with some examples. So our first example is 153. Taking the cube of every single digit of this number, we get the cube of 1, 5 and 3, which is 1 into 1 into 1 plus 5 into 5 into 5 plus 3 into 3 into 3. So their cubes are 1 plus 27 plus 125. Adding these three numbers, we get 153. So the sum of cube of every single digit of 153 is 153 itself. So it is an Armstrong number. Taking another example, 123. We take the cube of 1, 2 and 3, and these cubes are 1, 8 and 27. Adding these three numbers, we are not getting 123. So it is not an Armstrong number. Let's write the code to check whether a number is an Armstrong number or not. So here we have a blank sheet in Python in a script mode, which is saved by the name armstrongnum.python file. So let's start writing our code. First we will take a variable x in which the user will enter any integer value, and we are going to write this code to test any number with less than or equal to 6 digits. So we are going to give the limit number should be less than 6 times 9 and done. We have written our first line of the code to take input in a variable x. Continuing with the code, we will take a variable a which will be x modulus 10. So this step will remove the remaining part of the number except the unit digit, which is at the extreme right of the number, and we have separated one digit, as you know. To find whether number is an Armstrong number or not, we have to calculate the cube of every digit of that number. So we have separated the unit digit. In the next line we will take another variable b, and it will be x floor division 10. So this will separate the unit digit again, but in this case we will be left with the rest of the number. And in our third variable c, which will be b modulus 10, it will get us the unit digit of the number we were left by doing the floor division of x with 10. So we have separated first the unit digit and then the second digit from the extreme right. Let's repeat this step to separate all the digits. Here friends, you must be seeing that every time in all the floor divisions we are calculating with only one number x, but we want to be one digit removed every time we did a floor division. So we are doing this like first floor division is done with 10, while the second floor division is done with 100, and this third floor division is done with 1000, Then so we are adding one more 0 in the divisor of the floor division, so it will take down one more digit, and we are using the modular sign to get the unit digit from the quotient that will be left after the floor division. When we repeat this step, we will here have 6 moduluses here, which are in our variables a, c, e, g, I and k. So this code will test any number which has less than or equal to 6 digits, because we are separating 6 digits from the unit digit to the digit in the extreme left. You can repeat these steps you just have to remember that each time you repeat the step of these two lines is one step to separate any digit from our number, and each time you do this step you have to add a extra 0 in the floor division. So let's continue forward with the code. So we have a variable L here, which will be k into k into k. So we are doing what now? So here we have separated all the digits in the number, and now we are calculating the cube of every single digit. So our separated digits are these variables whose values we have got using these moduluses. And we have as I have told you earlier, these are our 6 variables which we have here, and we are getting the value of their cube in other 6 variables. So let's continue. So we have the variable L which have the cube of k. We have the variable M which have the cube of I. Then we have the variable N which have the cube of g, and continuing we have variable O with the cube of E. We have the variable P with the cube of C, and we have the variable Q with the cube of A finally. So now you must have remembered that we have discussed in the previously that to find the Armstrong number we have to add the cubes of every single digit. So we have did this in 3 steps. First, we have taken the value of a variable from the user, which will be the number he wants to test. Second, we are separating the digits in these steps. And third, we have calculated the cube of each and every variable or each and every digit which we have separated. Here we are using these variables for those digits. And lastly, we are going to add all of them in a variable y, which will be the sum of variable L, M, N, O, P and Q. So as we have done all the calculations using all these variables here, we will use a if-else statement condition to check if the number is an Armstrong number or not. So here we are putting the if condition y double equals to x. This is the thing to remember. that if you are checking if something is equal to any other thing, like these two variables we are comparing, x and y, so you have to put the equal sign twice in Python's if condition, and x is the variable which was the number taken by the user, and as the user entered the number, the y, which is the second variable we are comparing, is the sum of all the digits of that number, but it's the sum of the cube of every digit of that number which was entered in the variable x by the user. So if these two are equal, then the variable is x, which is the number entered, is a Armstrong number. But what if these two are not equal? In that case, the number will not be a Armstrong number. And by the else statement we are writing, if these two are not equal, print this is not a Armstrong number. So friends, as we have written and understood this code side by side, let us run this code and see if it works. So previously we have taken the example 153, and we have had calculated already that this is a Armstrong number. So let's see, and yes, it is working properly. This is a Armstrong number. We can again try it with a second example, which was 123, which was, according to our calculation, was not a Armstrong number. And yes, the computer is showing that this is not a Armstrong number. This means our code is working properly, and you can test this code on any other number for if you have any questions. If you didn't understand any part of this video, do leave a comment and like this video if you learned something new, and subscribe our channel for more informative videos. Thank you. Goodbye.